So we're starting out with this machine. This machine wants 5 digits for the program number. What's the first position of a program number in the CNC world? Oh, right on. And then I made a comment because that's this assignment number. That works for us. And then I made that other comment that's really handy. That way when I come back next quarter to run this, what was the stick out on this? You know, another good comment would be, let's go to edit. Another way, Damon. Another good comment would be this: 1.5 inch stock.
That's it's going way down low.
Hold on, baby bird, I'll feed you. Are you seeing it down at the bottom down there, kitties? Oh, not yet. Okay, 1.5 inch stock, and I'm going to hit insert. Oh, so my comment's in the right place, but now it also grabbed this stuff, which is okay. What I didn't do, by the way, I didn't put an end to block. Okay, that didn't work either. That's the hold the phone. End to block, insert. There. When I typed that whole comment, I didn't put an EOB there, an end to block, so it didn't end the block. Alright, cool. So there's another little useful bit of information that I need. Okay, so, geez, my safety line, right? I do have the G54 in the safety line. It's not wrong, but I do like having it in my first motion. Alright, G50 is what?
Max speed.
Yeah, max clamping speed. And I brought that down from, I think, 5,000 because I wasn't comfortable. And then I just canceled constant surface speed, turned the spindle on. And now there is a home command here, which is, it doesn't need to be here. I just made the habit of every time I did a tool change, I wanted to put a home command before it. So I didn't change in some dangerous place. I didn't change tools in a hazardous place. And then I called up tool, and I also put my insert number in there. So that's a roughen insert. And then we did all sorts of cool stuff. What I also did that we didn't talk about yet is before the M08, I put a block delete. Block delete works similar to op stop. An op stop is the M01, an optional stop that'll only stop there if I have the optional stop button pushed. Well, it's not going to go now. Let's go back to mem. If I have optional stop pushed, now it'll stop at every M01. For block delete, if I have the block delete button pushed, it's going to ignore everything after a, is that a backslash or a forward slash?
Forward slash. Forward slash.
Okay, forward. Whatever it is, we are now calling it forward. I deem it a forward slash. So now, it is going to ignore everything on the block with a forward slash at the beginning. So what I did is I went down to all of the coolant on blocks. I put that on its own block, and I put a forward slash, a block delete in front of it. So when I'm doing demos, we're not getting wet, or at least not very wet. Blood's different, but we won't be getting sprayed with stinky coolant. Okay, so that's on. So we'll have no coolant. What else did I do? Okay, so I'm going to verify that I did that to every M8, because I typically miss one, and you're kind of operating it from right here, and you get sprayed. So I'm going to look for the next M8. So I'm going to type M8, and I'm going to hit the down cursor, and it searches in the direction of the cursor I pushed. Okay, there's a block delete right on. M8 down, and it didn't find another one.
Computer's always right.
It is right. What's meaning is that the coolant is not being programmed on anyplace else. That sounds bad to me. Here, we're changing tools, turning the spindle on, going to, oh, there it is. Oh, why did it go?
Because it's too
Oh.
on the screen.
No, well, it could be. Could also be that I'm in mem mode. Let's try it again. M8 down, M8 down. Right on, interesting. Let's change to edit mode. I'm in edit mode because you see it up here. M8 down, M8 down. Interesting, it did let me look in mem mode, but only on the screen. That was weird. Okay, cool. So there's that one. Slash in front of it. M8 down. After the parting tool. We're looking good. We shouldn't get wet. Shouldn't. Definite maybe. All right.
If you're in the splash zone.
So we're ready to run the machine, I think. What I do before I run the machine is I have a checklist. Is the correct program loaded? 1937 for assignment 1. Yes. Are the correct tools loaded? My tool 1's a rougher, tool 2's a finisher, tool 3's a parting. Yes. Stay with the tools. Are the tools measured? Yes. Okay, so that's everything with tools, everything with program. Now, machine. Do I have the right programmed stock installed? It's 1/2 inch. I mean, it's 1.5 inches in diameter. Right on, I got the right diameter. I have the correct stick out. I had 4 inches of stick out. I was freaked out for a second there. But I verified. Alright, I have the right amount of stick out. So my work, the correct stock is loaded, the correct stick out is loaded, my work offset has been loaded. No, it hasn't. I just caught it. Where did I program the origin in relationship to the end of the stock? Inside the stock. The origin is inside the stock some amount. Alright? My head the whole time, we didn't really get down to brass tacks in the class on what should you do, because it's not an uber precise topic, especially in this part where I have a lot of stick out. I've got like an extra inch of stick out because it's tight stuff. I set my 0 when I touched off the face of the stock, but that's not the origin I programmed to. I programmed to an origin inside the stock by a distance. So I need to correct this work offset and place it inside the stock. So, for starters, we know I need to move it that way towards the chuck. Is that positive or negative? It's negative, correct. How much do I want to move it? I'm going to move it 30 thou. Now here's the deal about how much to move the work coordinate system into the stock is, how accurate can I be at putting 2 inches of stock sticking out? If I can't do that very well, then I probably need to move it in farther. So I'll be cutting stock the whole time. But I'm going to go with 30 thou. So to move it that way, what I'm going to do is I'm going to type negative 0.03, and I'm going to press the right enter key. That's going to add negative 30 thousandths to that. So before you ever change a number, do the math. What's it going to be? 0.475. It's going to add 30 thousandths. It's going to be 0.505. That sound right? Okay, good. If you don't do that, you will talk yourself into some stuff and never catch it. Done it. Because I'm super smart and I don't make mistakes. And then once you make enough, okay, let's come up with some systems to catch your genius ass making mistakes. All right, so how we doing? Oh, we're recording all that. All right. So, mem. So I need to have the mem mode button on to run a program, because it is running it from memory where this program lives. So I have to be in mem. So I'm in the correct mode. So if I hit cycle start now, I'll be making chips. But it's not the best display to be running it from. It would be much better if I had more information. So on the display, I'm going to go to current commands. So now I have a coordinate system up at the top. I'm just going to start at the top and work down. Let's go back to here. Let's get Kelly right sick. Let's get her throwing up proper.
I have a 6-hour drive after this.
You have a 3-hour tour? A 3-hour tour. Alright. 3 people have watched Gilligan's Island.
Or at least know the song.
Yeah. Okay, so I have some useful I still have my program up here. So I still have my G code up there, which I'm going to be looking at the whole time. But I also have a bunch more information. So I have a coordinate system over here. So machine coordinate system, out of all the coordinate systems, it's probably the least helpful to me. I'm going to press the up cursor, and I'm going to go down cursor, distance to go. So now, these numbers right at the top are going to display how much farther the tool needs to go to execute the active line of code. Handy stuff, especially when you're turning towards the chuck. How much farther do I have to go? I mean, I'm getting close to the chuck. You know, I want to stop before sparks. So that's good. Next is all the active G codes. For example, G54, it tells me what work offset we're using. Cutter comps will be in here, if cutter comps on or off. Active G codes. Over here, I have programmed feeds, actual feeds, programmed RPM, actual, program, commanded, and actual. Which tool number is going to be in the spindle? Spindle loads. Yeah, and down here, these big numbers is going to be my active feed rate and my active RPM. So really freaking handy. Okay, we ready to make some chips?